Okay, I'm going to read the short biography of William Thomson in this book. So, William Thomson lived 1824 to 1907 and was born in Ireland. His mom died at 6. He was educated early with his father, who was a professor of engineering and math. In 1834, when he was 10, him and his brothers went to Glasgow University. And in 1841, he entered Cambridge, where he was awarded for something. French School of Science. He did some more stuff. Got a professorship in 1846 at the age of 22, which he held for the rest of his life. In his work on heat and the laws of thermodynamics, Thomson was first hampered by his conception of heat as a conserved substance rather than a molecular motion that could be completely converted into another form of energy. Many other scientists of the time had the same misconception. After the study of both actual and theoretical heat engines, Thomson proposed in 1853 the second law of thermodynamics in the following form. It is impossible, by means of inanimate material agency, to derive mechanical effect from any portion of matter by cooling it below the temperature of the coldest of the surrounding objects. So now it's Cletus form. Thomson's proposition was an assertion, not a deviation based on probability theory. In the 1850s, Thomson applied his understanding of heat and thermodynamics to discuss the cooling of the Earth and the Sun. He argued that if these bodies had originated as hot molten balls, as believed, then the rate of cooling must have been much higher in the past, and temperature differences were higher. Consequently, geological activities such as winds and volcanoes, ultimately driven by heat flow, would have been more violent in the past, and these considerations contradicted the common geological wisdom, which held that geological conditions had not substantially changed over time. So Thomson was mild-mannered by nature and unwittingly thrown into this controversy. But in addition to his theoretical work on heat, electricity, and magnetism, he was keenly interested in the design of new instruments for measurement. In fact, he was exceptional in his combined abilities at theoretical work and instrumentation. In the mid-1850s, Thomson was recruited to serve on a project to lay an underwater telegraph cable between Ireland and Newfoundland, the first of its kind. The project was backed by a group of British industrialists, and basically he became rich and was knighted by Queen Victoria, not crowned. Thomson's guiding philosophy was that all physical phenomena should be reducible to mechanical models. He frequently championed other scientists' ideas, and he loved the sea and spent time on his yacht. Okay. From these interests came patents on a new kind of compass, a device for calculating tides, and a depth-finding equipment. Interesting. He had 2 marriages with no children and buried in London.